Now we have what is called the empirical rule. This is a rough guideline or a rule of thumb that says if your distribution is unimodal and symmetric, so that's important first, it has to have those two qualities, then what we can say is that approximately 68% of the observations will be within one standard deviation of the mean. Approximately 95% of the observations will be within two standard deviations of the mean. And approximately 99.7% of the observations will be within three standard deviations of the mean. So this is a way that that mean and that standard deviation coupled together really give us a lot of information. What this looks like image-wise is a unimodal symmetric distribution with the mean right in the center. Okay, so let's go from that mean, go out one standard deviation, two standard deviations, and three standard deviations to the right. And then also we could take that mean and go backwards one standard deviation, go backwards two standard deviations, or go backwards three standard deviations. So again, what this rule says, the empirical rule, also sometimes called the 68, 95, 99% rule, is that between these first two values, between whatever value this happens to be and whatever value this happens to be, 68% of the data falls between there. Between two standard deviations from the mean in either direction is where 95% of the data falls. And within three standard deviations, we've got 99.7% of the data. So it kind of shows, again, that spread, like where's the bulk of our data? And anything outside of three standard deviations is almost impossible to happen. There is only a 0.3% of being outside of that. So this is the basic image that you'll see in many places, but I want to write you an even more detailed image to help you with a lot of your problems online. So to make this even more detailed, let's take that 68% in the center. If there are 68% from here to here, what that means is that it's split 34% in each one of those chunks, because 34 and 34 would give that whole 68% chunk. Okay, then we could do some creative thinking. What that means also is that if there is 64% inside there, that if we were to go out this direction or out this direction, we could basically use the complement idea that if there are 68% inside there, we could do 1 minus 68%. And that's 32% on the outside of that. So if we want to go in either direction, we would say 32%, but it's split up into two what we would call tails. So there are 16% from this point on out, whatever that value is, and there are 16% from this point on out, wherever that is. So again, you could get asked questions, like they could give you this data value right here, for instance, and they could say, well, what percentage of your data values fall above that? Your answer would be 16% would fall above that. So we're just doing a lot of kind of filling in the gaps with percentages. Okay, if there are 95% of data observations within two standard deviations, but we already have 68% filled in right there. I'm going to do a little calculation out here. 95 minus 68 is 27. So there are 27% to be filled in here and here. So again, if we divide that 27% by 2 in order to look at each of those individual areas, we get 13.5. So there's 13.5% of the data in this chunk between 1 and 2 standard deviations above the mean. And there's also 13.5% between 1 and 2 standard deviations below the mean. And then again, we can look outward. If there are 95% between or within the 2 standard deviations, then how much is there outside of that? Well, if there's 95% inside, that means there's 5% outside, but that 5% is divided into 2 different areas. So there's 2.5% of data values above whatever this number is, and there's 2.5% of data values below whatever this data value is. Now let's do one more area here. Again, I could do some creative, or not creative, but I can do some subtractions here where I say, okay, if there's 99.7% inside the 3 standard deviations, but I've already gotten the 95% accounted for, 99.7 minus 95 means that there is 4.7% to be split amongst this and this area. Divide that in half is 2.35. So there are 2.35% here in this sliver and 2.35 in that bottom sliver between the 1 and 2 standard deviation marks. And then lastly, if you have 99.7% of your data values in between these two, that means there's 0.3% to be split amongst each one of these tails, which means there is 0.15% going this way and 0.15% going this way. Now this is a very, very detailed image. Most of them that you see will only have that 68, 95, and 99.7 labeled. But using this, you have every possible piece labeled, and you may want to use this on some of your assignments when you're asked to find certain values. So let's go ahead and look how this could be used. It says assume women's heights have a mean of 64 inches, which is 5'4", and a standard deviation of 2.5 inches. So I'm going to just draw out to the side here a very not pretty looking normal curve. The center is at 64. So I'm going to go ahead and count off my 3 standard deviations in either direction. So if I go up by 2.5 increments, my next one would be at 66.5, and then 69, and then 71.5. Again, this is the mean. And if I go down by 2.5% increments, I get 61.5, 59, and 56.5. So that's what the normal curve looks like here. And that was left out here. Assume women's heights are what we would say normally distributed, which means that they are unimodal and symmetric. And that's true, they are. What percentage of women fall between 61.5 inches and 66.5 inches? So what we can do is we can see, okay, well here's my mean, that is the same thing as asking within 1 standard deviation of the mean. So by the empirical rule, we can say that that's 68%. What percent of women are less than 61.5 inches, so this direction, or taller than 66.5 inches? So this is a real question that you could come across. And again, we showed that on this kind of master empirical rule image here, that if we go outside of that 68%, there's 16% on either side, or 32% total because it's 16% here and 16% here. What percentage of women are less than 61.5 inches tall? Well, that's just this lower area here, so that would just be 16%. 99.7% of all women fall in between what heights? Okay, so I can use this image in the other direction. I already labeled the entire thing. I like to do that just so that I can answer any question they might ask. But 99.7 is the within 3 standard deviations. So for us, those values would be between 56.5 inches and 71.5 inches. So you can use that rule either direction to either give the percentages or to find the heights or the values given the percentages.